Okay. Come to close. We will continue our discussion on how to implement the Q learning for our code game. And for Q learning, basically, the major data structure is so-called the Q table. And the Q table, you can imagine that the row corresponding to the state, current state of the environment, and the column corresponding to the possible action. And the crucial point is to choose action is very easy. Just look at the row and choose the action that gives you the largest value. Because the Q table, the entry is supposed to tell you which action will have the biggest potential to get the best result. So of course, you just choose the one that gives you the most promising action. But on the other hand, the most important point about the Q reinforcement learning is the way that you update the content of the Q table. And this is the crux of the whole technique. And basically, every action or every step taken by the agent, after that, they look at two things. The first thing is what action has been taken. So suppose when it entered the state, it in state S, okay, and the so-called principle of optimality by the Boltzmann use the best action. So this is the current, say, action taken by the agent. Now we're trying to update the Q value of this SA entry. In order to do that, then it took one step forward and try to take the action, okay, after, say, get using action A on the current state S, you get a new state S part. Okay, now of course you get it because this is what you have chosen to take the action. So you will find from the environment the new state, and also from the current Q table, you can choose the best action for this state. Okay, so this basically is the next step, next future step, following step that you are going to take. Okay, so the crucial point is the difference of this value. If after taking this step and lead you to a new state, such that the best possible action will give you a very small Q value. So that means that if you take this, okay, at this vector stage, give you some promising Q value for you, but after you get into this trap, then you will enter a situation that no matter which action you take, you will be a dead end, for example. So in this case, then of course, you need to update this one because it is over optimistic. Okay, because once you take this and then you get into that state. On the other hand, after taking this stage, you will be led to a state that will have a much better Q value. So that means that this stage, the prediction is kind of too conservative because once you take the right action, you will be in a much more promising state. So it will usually increase the Q value, okay, for FQA. So this, okay, the difference here are the cost, the central, say, information that you need to take into account. But after this stage, which one is larger to determine whether you should increase or decrease the current Q value. But that's not enough because the magnitude that makes the change are also very important because you don't want to, say, make the change too dramatic so that one single step will kind of mess up all the knowledge that you have accumulated at that point. Okay, if you say one single step will say almost assign almost new value to the Q. That all the, say, knowledge that you have accumulated before that step basically is wrong. So this is why you want to take a sound factor, okay, to make sure that this, okay, new situation will not kind of mess up all the knowledge that you have learned earlier. So you just take this effect and stop this time. So you find that the number here, the example is pretty small, okay? And also, this is learning rate that will kind of further limit the change of your algorithm after each learning step. Okay, so this is, if you look at Q learning, basically this is the most commonly, say, standard line for you to learn here. Okay, now in order to show you how to work on develop a Q learning to solve a Catpo problem. And if you still remember the Catpo problem, basically, okay, will give you the state with 4 numbers. Okay, that will be told you, okay, at the state will told you the cut position, the cut velocity, and also about the pole is angle with the vertical line, and also the angular velocity of the pole. So these two are measured in terms of radius. Or even though you see that what will is equivalent to say 24 degrees, and this is minus 24 degree and a positive 24 degree. So you can imagine that though you have a pole here, and then this is okay. The maximum say angle here is 24 degree, and then the maximum angle is minus 24 degree. And if the pole falling out of this shaped fan, then the game finished and move on. Okay, we cannot save it anymore. Okay, while the velocity basically it does not give you any constraint, okay. But of course it cannot be too large because if it is too large, basically it's kind of difficult to recover. Okay. Now, the problem here is now once we know that, then we in this example we will only use the pole information. Okay, and just don't take the first two stay on the card. Okay, into account. So we will only use two. And for this, the last two state, we have a problem. Namely, that is a value are kind of a continuous number. Okay, basically, you can have many possible values for each of these states. And remember that we are working on a Q table. Of course, the size of this Q table cannot be too large. Okay. Why? Because if the table has many columns, that means that you need to get the right Q value for a lot of entries. And if in this case, if the running is not, say, number of running is not large enough, then basically you still even do not have chance to fill out the value, let alone to get the best possible value. So the main gap that we are facing is that what the environment gives us is a continuous number, but our Q value can only handle a small number, okay, of rows to handle. So in order to handle this kind of situation, which is kind of very commonly encountered in different kind of application, one important, say, technique that we are going to use is so-called I don't know how to say discretize. Okay, discretize the value. So in other words, just so use spinning. In this range of values, say for example, from minus 24 degree and positive 24 degree. Okay, suppose we can use a 6 beam to divide it. So basically, for minus 24 to minus 18 will be 1 beam. And minus 18 to minus, say, 12 beam degree will be the second beam, so on. Okay, so basically, we are going to divide the angle into, say, for example, 6 different consecutive intervals. Each interval is a beam. Okay, and after that, then whenever the environment say that this state will have the angle minus 20, say for example, then you know that it will be in the leftmost group. Okay, so this is what we have. Now, of course, it's not that again that difficult to divide the beams, but we are lazy, so we will only use some already say utility that have been implemented for us. Okay, and this utility is provided by sklearn again, and under this preprocessing library, in which there's a function called k-beam discretizer. Okay, so this allows you to divide the value that you need to handle into a certain number of beams. So let us see how to use it. Now, this part, this two lines are just those for you divide the beam. Okay. Now, but when we go ahead, we need to make a decision. And because our state are containing two values, so you can imagine that for Q table, every row are specified by two beams. Okay, one beam for the angle, one beam for the velocity. So it's two values. Now, in this example, we decided that we will divide the angle, pole angle into 6 beams. Okay, if you try to say, so totally the degree is minus 24 all the way up to 24 degrees. So totally the range is 48 degrees and divided by 6. Okay, so basically, okay, each degree will say cover 8 degrees. Okay, okay, so this is one for one, and also for the velocity, even though it is infinity, but we will just start with minus 50 degrees up and then all the way up to another minus 50 degrees, all the way up to positive 50 degrees. Okay, because this is kind of reasonable and setting to the infinity. So this is what we are going to use to label the state. Okay, the state basically contains two numbers. The first number would be for the angle, and second number the beam for the velocity. Okay, so basically given a state, and then decide the action, and then call this action to the couple and get this state. Okay, and then after that we use the same discretizer to see the new state's value corresponding to which beam, and then you know the new state. Okay, so this is in general. Okay, so in order to do that, we first specify the number of beams. So in this case, basically it is a couple containing 6 beams for the first whole angle and 12 beams for the second angle. Okay, and then we will specify the lower bound. Okay, for lower bound for the angle and the velocity. The angle is minus 0.14. So this is the lower bound. Okay, I print this out. Okay, the lower bound is minus 4188. So this one. So this is the lower bound. Upper bound, another lower bound for the velocity is minus 50 degrees. So if you change manually to the radian, then you see that it gives you minus 0.87. Okay, so this is for the lower bound on this tube. Okay, this is minus 50 degrees. And the upper bound is this value, okay, 0.18. Okay, and together with this one, positive 0.81. So this gives you both the lower bound for the value and upper bound for the value. Once you do that, then you can just simply call the KB displacer. Okay. And of course, you should tell in the translation then the information about the pin. So you just tell the pin will be okay contain 6 a state of 6 pin for one, and then 12 pin for the other. Okay, and ordinal basically it just means that the pin has order. Okay, of course, because this is odd number is very important. Okay, so the smaller the angle, the more dangerous the situation is. So if because the value here has order, so the corresponding state has order. Okay, so make sure that okay the range of the being the left nodes will have the smallest order, for example. Okay, so this gives you some order ordering, and the strategy here is uniform. Uniform, which means that whether you want to divide the range okay uniformly into bits. Okay. I suppose this is a very commonly used strategy, but there are others. Okay, but anyway, we don't get into that. So after this one, you just call okay the discretizer estimate FEST, and then call feed on this lower bound and upper bound. Okay, so after that, keep on. What do you get? Basically, you don't need to worry too much about the underlying operation. But what you get will be something like this. When you call this one, then later you can imagine that you have a new state that will give you the number, okay, for whole angle and whole angular velocity. All you need to do is to call this function and use these two numbers as argument. Then what you get is the corresponding p. Okay, so you don't need to know exactly how the mapping is done. This model will done it for you. All you need is to know that the value, okay, will give you the state. Okay, and that's it. Okay, and in order to do that, that's a little bit not that obvious. Okay, so maybe I just need to explain it. Okay, the Q table. Now the Q table basically will have okay. This is for the actions. So this is taking action. Remember the couple example. Action 0 means push to the left, and action 1 push to the right. So this column may have content either 0 and 1, corresponding to the action either left or right. Okay. So more importantly is about the state here. Remember, now the state basically has okay 16 for one component and 12 for another component. Okay. So in order to create this table, we need to have defined a number array such that of course it has two columns, one for action left and one for action 2. And also you can see this one 6 and 12 as the label of every row. Okay, and the label will contain okay 6 numbers together with one of the 12 numbers. Okay, so when you want to find okay a particular row for a particular state, all you need is to give a state for the first number and the state of the second number. After that, you will get the corresponding row. Okay, so is it clear? So basically, it's a large table. The table has only 2 columns. So the important point is the label of every row. The label of every row is 2 numbers. Okay. One number will be the bin, for the angular angle, and the other number is the angle velocity of the ball. Okay, so this is in order to do that, then you just define this number array, initially set it to 0, and if you print that out, now this is the table. And this is for first column, row 1, first column, row 2, first column. So you check that basically it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically 12. Okay, and then the 16 that you will find that you have this kind of array 6 times. You can check it yourself. So this is what corresponding to the Q table. Okay, now after that, everything will be very easy to handle. Okay, so let's go through it. Okay, this is the learning rate. You see that is only 0.1, and then the discount factor is 0.9. Discount factor 0.9, okay, is large. So remember that this is the discount factor. So this is the discount factor. Okay, so 0.9. Okay, as I mentioned that the nomenclature here it should be belonging to parenthesis to put this visual subtraction together. Okay, so anyway, here is what we have. Yeah. So I'm wrong. Basically, the discount factor will discount the new state. So, anyway, so let us move on. So what we are going to do will be first, I call the environment to reset it so that to prepare us to start a whole new say game. And now here, now every state, basically, we will need to know our initial state. In order to know our initial state, then we need to check the environment. Okay, this will give us the new state after the reset. But remember, okay, the state contains 4 numbers. The first 2 numbers corresponding to the card, and last 2 corresponding to the pole. And we are only interested in the pole, which is okay, last 2. So state 2 and state 3 will be the angle, and then the angular velocity, and then we call SK transform to say assign these 2 values to the corresponding beat. Okay, so initially, for example, this is 0, okay, and this is also 0, and basically you can imagine that this is the middle beat. Okay, so, something like that. Okay, and now after that you have the state, and you will see that in order to use it as an index, so we need integer, so we just convert that to the integer. When you print it out, basically, okay, they are the same numbers with say some floating point number. So this is just converted okay, into integer so that you can call it as an index. So after that, basically, just like our previous example, you keep on okay, running the code by taking the corresponding action in each step and then update the Q table. Okay, and again until you fail. Okay, so how to do that? Now, this is very important. So suppose now you have in the ith row corresponding to the state. Yes, okay, this state corresponding to I row. Then I row has 2 columns. 1 column for a pushing left, another column for pushing right. According to the so-called principle of optimality, that it says that you should choose the action that gives you the largest Q value in this column. Okay, so basically, there's 2 numbers, 0 and 1, column 0 and column 1, and then we look at the 2 numbers in this row corresponding to the current state, and find which one is the larger, and then choose that action. Okay. Now, I just argue that this is exactly what we need to do. Okay. So basically, argument maps on the current row. It's just say that in this row, which is two number, okay, the one with index 0 and the number of index 1, okay, argument max is, okay, find the maximum value and tell me what is its index or what is its position. So suppose action 0 gives you the Q value 0.5, and action 1 gives you the Q value 0.9, say for example. Of course, 0.9 is larger. Okay, so you want to take action that gives you 0.9. Okay, but of course, you don't need to know 0.9. All you need to know is the action. Okay. Where is the index that gives you this large number? Whether it is the index 0 gives you this 0.9 number, or whether index 1 gives you the 0.9 number. Okay, so in order to achieve this effect, namely that you don't want to know the actual value, but you want to know which index. So you are not calling max, okay, because the usual max function will only give you the maximum value among the list. Okay, we call argument max. That will not tell you the actual value of the maximum, but will tell you which index in this list, okay, will give you the maximum. Okay, so if you call it in our case, that means that we tell you which action will give you the maximum Q value. Okay, so after that, then of course, and take the action as we have done in the previous random start example, and then it gives you the new state. The wall is always 1. Then it's showing whether the ball has obstacle or the card has already fall out, and then some information that is not that relevant to us. Okay, then this state, then the last two is for the pole. So again, we just convert it into corresponding state. Okay, and then if you look at this one, basically give you more than one row. So you not what you need to know is the 0 row. Okay, so I forgot to mention. Okay, so this just mentioned that the transformation that we want to get is at the 0 row. Okay, you don't need to worry about the moment. So this is what we have, a new state, and then convert into integer, and then repeat, get the next action, then you take the next action, see what we get to, and then after that, you just using the new state, new action. Okay, now I'm sorry, okay, in fact, in this one, basically, the discount factor is not discount on the difference, but discount on the new state, new actions value. Okay, and then after that, we'll make the difference together with before, and then times a learning factor, and then so that we can update the corresponding entry in the Q table 1 by 1, get the new state, and we can step. Okay, so it's pretty straightforward, but only the kind of detail that you need to be a little bit careful to see how actually the value will change. Okay, so I leave it to you to write the program and see it. Okay, I can tell you that in the past 2 semesters, many students has implemented to do the assignment. Okay, and the performance is not very good. It's about 200 something. Okay, but it's much better already than the random active sample there. Okay, so as I mentioned, the best one is can reach millions. So basically, Because this is kind of oversimple. So of course, you can say better the skill, and others say reinforcement learning with repeatable design. Okay, so this is an example for using the pure learning sample. Any question? Okay, now, of course, our major objective is to try to apply reinforcement learning algorithm to actually help us learn how to improve trading automatically. Okay. And in order to do that, follow the same, say, step. The first is to decide an environment that will help us to, say, get the reward for every step and change the new state and correctly so that we can follow reasonably for help us to make an improvement of our internal state in order to make better, say, judgment after a longer sequence of training. Okay, so basically we are doing this, okay, direction. First, now the environment. Okay. Again, we will not implement the environment ourselves. So we are going to use again the gene, OpenAI genes. Okay, and it has a sub-library called gene any trading. Okay, intentionally, this library will provide environment for every possible kind of trading. Okay, and in particular, you can find three environment providers called the trading environment, foreign exchange environment, and stock environment. Okay, so this is the environment that you can find very easily. And in our example, we are trying to work on the stock market. So we will look at this stock environment. Okay. So basically, this stock environment will provide all the necessary information and the processing for us to implement our reinforcement learning algorithm for training. Okay. So this is what we have in any trade. Now, anyway, just show you how different environments provided by gene. In particular, we were working on one of them. Okay, for gene and trading. For there's other different kinds of environment that we can use. And so again, we need to the example we given here is a very limited example. So basically, we need to say kind of check important website on AI, on machine learning, to see the latest development or latest new, say, facility, library that this new major AI company provides. So this is also the best way to keep you updated on the current situation. Okay. Now, basically, there's a lot of argument for any trading, but we are only focused on a few of them. The first is the trading position. Okay, so basically, I'm not that good in finance, but this trading position basically is a judgment. Okay, so for example, a particular trading day, then you look at the the trend of the stock price and all the other related information. You decide to think whether that particular stock is in a long position or whether it is in a short position. Okay. So this is the major prediction that your machine learning algorithm needs to make. Okay. So what is for long position? That means that now after all the previous trading information, you decided that this say stock has good potential. Okay. So it will kind of maintain the current stock price, or even better, it will say kind of giving a highest price in kind of a near future. Okay, so in other words, at this moment, the decision that you will make is kind of holding the stock longer. So this is the long position. That means that stay calm. Okay, don't be panic. This is kind of give you a good potential if you keep the stock a little bit longer. While the short position is saying that, okay, the thing is not that good. Okay, then you should just try to sell the stock. Don't say keep it too long, because in the near future, in a rather short period of time, then the price will kind of drop, okay, so that you will lose. Okay, so this is long and short position. Of course, this position basically will depending on, in our case, is previous stock price trend, and you need to say the machine learning algorithm will need to relate the previous stock price trend in order to make a decision whether the current trading day will give you a long or a short position. Okay, so this is what the learning will need. Now, of course, this long and short position may not be too informative to see how the this kind of prediction will eventually lead you to say profit or lead you to some losses. Okay, because just tell you this is long and short may not. Okay. So eventually for investor, basically I start from $1 million. Okay, I don't bother whether the prediction into trade. I want to know 1 year later how much more money can I say gain in this investment. So the environment also provides this kind of information for us, namely that it will tell you, okay, for every trading day, is prediction on whether the stock is at a long or at a short position of that trading day. Okay, but also at the same time, it will start trying to adopt some investment say strategy, depending on the prediction or the judgment on whether the trading day is long or short. So basically, based on this long, short, say, information provided by the machine learning algorithm, then the environment and trading will apply some standard investment strategy. Okay, based on the initial investment is $1. Okay, and then based on this strategy, working on the prediction on the long short position, as at the end, okay, you will check how much profit you have gained or how much loss you have gained. Okay, and then this one will give you some idea on whether the current RL reinforcement learning algorithm are good enough. Okay, because the output for the reinforcement learning algorithm is long and short. Okay, and the environment gives you one more step of information that will tell you following this prediction whether you will gain or you will lose. Okay, so this is also okay. Okay, so this is also give you the profit. Initially, you have a starting money of $1 or 1 unit of dollar. And that basically after the for all the testing, okay, for example, and then you will get the final money based on the long and short prediction, and you will know the profit. And once you will based on this one, you will see whether the reinforcement learning algorithm appears now. Okay. Now the window size is a little bit explanation. Okay. So what we can get from say Yahoo Finance is a long series of the price of some stock over a particular trading period. So you know the stock price for every trading day in this period. Usually it's thousands of that, 1,000, 100, 200,000 such a price. Okay. Now the reinforcement learning algorithm, basically what we are doing is it just it will not use all the 1,000 and something, 100 something stock price in order to make one single training step. No, basically it will divide it into just like what we have done in LSTM, many say small window of trading days, such that each window will be long enough that will show how to relay the trend of the stock price in this period with the prediction. Okay. And this should not be too long, because too long, first it will take too much time in the longer and the training, and then also if too long, then it will make long memory. Okay, because take the jargon of long and short memory. Longer memory will kind of corrupt the information of the short memory and make the prediction of it. Okay, so what I'm going to say is just like what we have done in LSTM. Basically, out of these thousands of stock price, we need to chop it into a chunk of trading day. Okay, and the number of trading day in each chunk is called a window size. So you can imagine that we have a sliding window of size, say for example 10. Okay, then you have the first 10 days stock price, okay, for one particular training, and that shift it to the another foreign day. It's day 2 to day 11. This is another chunk of 10 days for the training, and then day 3 and day 12, another chunk, so on and so forth. So this is called window size. Okay. Now, basically, what we are going to do is to follow the same step that we approach that we have for cut code. So we will just make use of some tools for us to prepare the training data. Okay, so this part is a little bit different from the cut code. But then we will first show you an example to take random step. Okay, that in order to see how it performs for some random action, and then we will apply some say well-established algorithm, okay, to apply them to do the RL trading and see how they the performance will be different. So it's first we work on the random action, okay. Okay, so let us go through this random action example and see what we get. Okay. Now, again, in order to make use of the environment, so we need to import gene and trading. I don't know where we need to import here, but anyway, we do it for that object. And depending on the platform that we use, if you use say Collab, then it's better to say install any trading or Gym and life finance all together to make sure that they are in the Collab for you to use. Okay, and then we import the necessary library for the processing of the data, like NumPy and pandas, and also this one for the visualization of the data. Okay, this part as usual, we call Y Finance to call pandas data reader to get the data of the Y Finance on again our old friend MPR. Okay, the starting period will be 2020 January 1st, and the ending period will be 2021. Okay, June 30th. Okay. Now, again, I'm sorry. Later in our example on sentiment analysis, then you will know why. But anyway, in this example, you don't need to make use of this function or data. Okay, later you will see why in some application we need it, but for this example, we don't need it. Okay, basically, you can just say substitute, okay, this start with like this strings, okay, and substitute this with this string, and it's just like our previous example, and you will get the correct data, and the data will be stored in the data frame for the app example. Okay, and after that, we can use Octane tools to show the movement of the stock price here. Okay, this is the stock price over the trading over the trading period. Okay, and we are looking at the closing price of every trading day. This is what we have this moment. So basically, what we need to do is to run this program, and then we want to see for so this is the stock price. Then we will only work on the first 200 days. Okay, sample, and then for each trading day, we'll try to see what the action will give us. So the first action will say that this is a short position, and long position, and so on. Okay, and all of them, the others in our example is say is determined random. Okay, and that in fact you do it in this way, then you see that the profit is pretty say horrible, because you start with 1 unit, but now at the end you only get 0.3 units left. Okay, so this is what we extracted. Okay, so so what we need is to prepare the data. What we get is a long series of stock price over a long trading period. But as I mentioned, we need to kind of chop them into small windows so that each window will give us an appropriate past history for you to do the learning. Okay, so in order to chop the window, so this is what we have. And basically, this is what we get is you call any trading dream, okay, to make an environment, and then of course you are calling the environment, the library. Remember, we are working on stock, so we have a stock environment and on the version 0. Okay, so this just like couple. Okay, example, you have a name of the environment you made. Okay, and now here is give you the whole period of stock price. Okay, and you can imagine that this is all the stock price over this period, and then it put it into this environment. Now the frame bound. Basically, the frame bound means that the environment will only work on the first 200 stock price. Okay, so even though there's a lot of stock here, so I don't know how many of them, maybe 500 something. So we'll only work on the 200 stock price in the environment. So this environment, basically, you will see that it will provide window that moves through this period of time. Okay? For each move, we will create a window for you for the training. Okay, so now let us decide what is the window size, which is defined by this argument. Keyword window is 5. That means that out of all the stock price, we will chop it into window of size 5, one by one. Okay. So let's see what it gives us. And initially, you can use the environment's function called price to see the fundamental, the basic period of price that we're working on. So you see there's a lot of that. Basically, this is the closing price, for the MDR. Okay, and if you look at a state, later you will see how to find it, but a state basically is a window of 5 trading days. Okay, 5 trading days. For example, it's starting from here. So the first 5 trading days is 1, 2, 3, 4, 5. So the last one is 40, 45 for 28. Okay. Okay, right. So basically, it's very interesting. When we start, it will also give the difference of the today's price with the previous price, today of the previous, the stock price of the previous day. So even though this window, the first window is 44.7000, then this one will show you the difference between today's stock price with the stock price of yesterday. Okay, and you see minus here, that means that today the stock price dropped 0.2 units. Okay. So now in order to make that this is meaningful, so even though you start from here, basically you cannot start from 45 or something, because for this you do not have previous day. So the first day that we work on will be here, so that you will have difference between this day and the previous day in order to make this value meaningful. So this is the first day of the window, second day of the window, and this is the difference between this day and the previous day is also dropping. Okay, and third day, fourth day, and the fifth day. So totally a window of 5 days, and this is the stock price change on the consecutive day. Okay, so this is the state that you will get. Okay, so you can imagine what we will see with you. Okay, initially you have one state. Okay, and then the other firm need to take an action, and that action basically is to decide whether it's a long or short position. Okay, then afterward you will move to the next stage. A very important point here is that the next stage basically is independent on the action of the RLR, because the trading, okay, of one particular investor is too small that it also makes negligible effect on the overall, okay, market. Okay, so in other words, no matter which prediction that your algorithm will make, the state provided by this auto trading basically fixed in before we even run the algorithm, because this is the first state. The next state we will just move the window one position right, and all the data are already fixed here. So the next window basically is already fixed, no matter what action that your algorithm takes. Okay, so you see that the state will be independent of the action. So once you have the data frame fixed and put into the environment domain, then all the intermediate state is already determined. Okay, so they all the information will be something like when you make a decision, then the agent will look at what is the price of the next step. Okay, and what is the price of the next step? And the agent will, based on this, will try to change its internal knowledge in order to make better guess. Okay, so if in this sense it's very similar to the LSTM algorithm. Okay, so work on some short period of history, based on it, learn some trend in order to make better knowledge. Okay, that will give you better decision in the future. So this is the state, and this is the algorithm. Okay, the action basically either 0 and 1 for the long and short position, and then every time you can call the environment step, okay, with the action, and then give you observation, report, time, and information. Okay, I've checked this before. Basically, it's always 0. And anyway, the observation is the new window, and you can check it yourself. Okay, and then you keep on doing that until done. That means that you have reached enough step, because your set the window is only 200. So basically, eventually, your window will move to the end of this period, and done will be true. Okay, so this is what you have. Okay, and after that, you just print. So it means nothing here, because the action you take is a random action. So this sample is not necessary. You can just set a random number of 0 and 1. In fact, you call this one and print it out, it's also give you a random number of 0 and 1. So corresponding to a random action, use that action to take one step, and the environment simply will give you the window for the next 5 days. Okay, shift the window by 1 position right. Basically, this is what. Okay. After that, then you can call environment render all. That will say show all the actions that you have taken, and then also show based on those actions how well you have performed. So if you call random all and then show the figure, okay, so this is about the claim that I've already mentioned. Okay, and this is sample I just mentioned on 0 and 1. Okay, so I've already covered it. So basically, you can check it yourself. Okay, what I'm going to say is, okay, the result here, that every day, this is the actual random action that I take. Okay, short, long, and so on and so forth. Based on this, say, trading position predicted by this random action. Okay, and the environment will try to use this information to do the trading according to some routing strategy, and then it will tell, okay, the user, okay, whether this long and short position detection will lead you to profit or not. In this case, even though it says that it's profit, but actually it's a big loss because you start from 1 unit, at the end you only have 0.36 unit left. Okay, so but this is what you expect. Okay. As a matter of fact, if you look at some, okay, some factor strategy, okay, and then it will see that the total profit is positive, it's 1.1 something. Okay, so now, any question up to this point? Okay, so now, we are going to make use of one standard reinforcement learning algorithm that we can provided by the standard baseline. Okay. So now we see that any trading is an environment that helps us to say prepare the data for train for running our reinforcement learning algorithm. But instead of taking random action, we will try to work on some real reinforcement learning algorithm. And basically, here is a library provided by a standard baseline. Okay, that will this library also provided by OpenAI. Okay, and it will give us many different best reinforcement learning algorithms for different kinds of applications. And here is a copy from the document on post on the standard baseline web page, and it shows a lot of different kind of well-established and proven algorithm for reinforcement learning. Okay, in particular, there's a lot of them. One good thing about this standard baseline is that you can go for each of the algorithm, you go to a document page, and it will describe briefly what those how this algorithm work, and also it will show you the paper, okay, that propose this algorithm, and then you can get a deeper understanding. Okay, and in our example here, I will just use the first one, A to C, okay, that we will use it to try to do the reinforcement learning in order to see how to apply it to make some meaningful prediction of the long shot. Okay. So this is the name A to C is called advanced actor critical. This basically is quite complicated, but unfortunately we only need to use the API in order to go through the algorithm. Okay, and this is the program. Again, all the usual library for installation, but in particular, we need to bring in the stable baseline 3, the latest algorithm, the library for storing, okay, the reinforcement learning algorithm A to C that we want to use. In particular, okay, you can just from stable baseline 3 to import the reinforcement learning algorithm A to C. Okay, and also now there's something a little bit out of our scope here, but need to use it is because when you call A to C, and A to C, the internal algorithm basically will work in this way. It will implement not one single environment, but will implement different environments and will, for each environment, it will execute, its action using different, kind of reinforcement learning. This kind of, active will means that if each of these, environment gives you the result, the critic will try to evaluate each of the action of this different algorithm, and that it will use some, measure in order to kind of get some consensus about this different action taken by different methods in order to try to come up with the best one. Okay, so this is called so-called actor fitting. Okay, so basically it's kind of some critics to judge which action taken by different environment will be the best way to do that. Okay, so in order to make use of this kind of idea, so the algorithm should have the capability to create the environment on its own. That means that at some point, maybe the algorithm will want to decide that I want to start a new environment to doing something similar in order to give the critics some better, information to make their judgment. Okay, so basically, what is something new here is we need to give information about how to create our standard environment, to A to C, so that A to C can, in the internal, part of the program, can make use of information to create a correct environment for their use at any time. Okay, so in order to do that, then we need to import a library called dummy environment. Okay, forget about it. Okay, dummy environment that will give you the basic information about the environment. Remember, we need to tell the window size, where to get the data, that kind of stuff. Okay, and then this will help give to the A to C in order for it to create an environment. Okay, now of course we cannot get into the heart of A to C, so basically we cannot discuss how A to C make use of it. Okay, but what we need is to provide or to tell A to C the basic environment. Okay, but we need to use in this execution. Okay, so this is what we need. Okay, so basically, we need to create a kind of a data structure that contains information for creating an environment. And how to do that? Basically, we will create a function. Okay, so if you know Python, this is the shorthand for creating a function called lambda function. Basically, it tells you, calling gmake, which will use this stop, where to get the basic stop price, and then how to do the which is starting and which end of trading and legal side. So this is all the basic information, for the environment. In our previous example, this will just use only once because we have only one environment, so we just create ourselves. But here, instead of actually creating we implement it as a function, okay? And then we pass the function to this dummy vector environment, okay? That means that by passing this environment makers, that this is essentially a function. Calling it will get us all the necessary arguments to create the right environment for the group. Okay, so this part basically it will be passed, okay, in as a kind of a dynamic way to create the environment instead of a standard environment created by the user at that point. Basically, it just gives you the function for creating that environment. Okay, so this is it. After that, then we call A to C. A to C, I can't go into that. A to C has a lot of different ways to do the reinforcement learning. One of them is to make use of the straightforward neural network. So we use that policy together with the environment, with the environment maker, okay, and run it, okay. And after that, then we learn it. Total time step is 2000. That means that you know that the time frame is only less than 100. So after running for train for 100, okay, step, then you don't have enough data. Okay, so this number of steps will not be enough, long enough for the algorithm to do the right training amount of training. So what you expect here will be something like that, just like what you see that when I describe the app pod. Okay, so it will say use instead of one app pod, you use 2000 app pod. 2000 app pod, that means that after 100 steps, we make use up all the data, and of course we will have some vector coefficient value that we find. This is for one app pod, and based on this vector coefficient, then we train, okay, using the same kind of environment again, okay, and all the environment, and then run it again, but with this new environment, okay, and then your reinforcement will kind of make another improvement on this after this training. So you can imagine that you just keep on doing this training on a particular fixed environment, and then you may expect that eventually it will give you, say, some meaningful prediction of the trading position. Okay, I know. This is something that I didn't think about it earlier, but it seems to me that for the standard, say, machine learning, basically is say supervised learning, that kind of thing. The major issue they always say worry about is overfitting. But for reinforcement learning, basically for the example that I've come across, they seldom worry about overfitting. Okay. Maybe there's something fundamental that I don't know. Okay, but that's something that I find it amazing. Okay, because all the other machine learning problems, overfitting is a major concern. But for reinforcement learning, it seems that they don't care. Okay, maybe I missed something, or maybe I have not read enough, say, material about reinforcement learning. Maybe this is something that we may also be aware, so that you may later see how to use it. Okay, so now after doing that, we can just like what we have done in doing the random action, we set the environment and get the observation. Later I will explain it here. Okay, and then make a prediction, and then we get a new state, based on the new state, new observation, then we can proceed to the next round. Until that, when done, that means that we have finished 2000, say, at or then we will play. Okay? Now, this observation, basically, remember the observation is if you stay or the window. Okay, the observation will give you the window of 5 or the sequence of window of 5. Okay, and they essentially is a 2D array. Okay, it happens that when the A to C, they need the input instead of 2 dimensions, they want 3 dimensions. So all we need is to just add 1 new dimension. And it happens that it is not rare. As a matter of fact, there are many, say, application or library require this extra steps on artificially just add 1 more dimension to existing data set without doing anything. Okay, and since this is so commonly used, so a NumPy also provide a way for us to add a new dimension, another extra dimension to an existing NumPy array. Okay, so to do that, basically, we want to say add a new dimension on the observation this data set. Okay, then of course the remaining dimension should not change because we just artificially add a new more dimension. So you see this dot, that means that you don't need to specify. Okay, it will keep using the original. But all you are doing here is at the beginning, you add 1 dimension. Okay, so you add 1 more value here. And in order to say, tell NumPy that you are adding 1 new dimension, so it will give you a special value. So that based on this one, NumPy know what we want. Okay, it's called new access. Okay, new access means that you have a new dimension, so you have a new access. Okay, so you just give a new access, okay, as 1 dimension at the beginning, and then all the rest you just touch dot, means that this is all the remaining will be equal to the original NumPy array. Okay, so this is particular what you need to have got. So this is the original OVS in this example. And now if you add a new dimension, basically it just add 1 more dimension without any change. Okay. Why you need to do that is because A to C, the input required and something like that. Okay, so if sometimes as a user you need to say massage your data in order to fit the requirement of the machine learning program that you want to do. So this is one particular. After you make the correct dimension, you just call predict, and then it gives you the new state as well as the action. So the new state here, as I mentioned, will not have any particular meaning here because the state will eventually depending on predetermined by the original data. So we just say we'll not use it, but still we need it in order to fit the requirement of the output of the okay, so this is what we have. Okay, and this after doing the training of 2000 staff and you have a model, then you run the environment all over again. But now the time frame here is not so the training time frame is 5 to 100. Now after that, then the testing time frame will be 90 to 110. So you see that I treat a little bit so that we have some overlap, so we can get the benefit of some of the training. So, but eventually we have 100 at the end, and then we make the environment run the program all over again. But this time, basically, is only for this part of the testing. And then after that, we can use visual rendering. Then you see that in this 90 to 100 stop period, basically it will tell you the prediction of A to C. Okay? It's kind of reasoning. Okay, so it's short. This is not in good way. Okay, so now this is short, and this is the short. Okay, right? Of course, in this case, the algorithm cannot make decision that this is another day is a long position. Okay, because only when it have a raise that it can determine this is a long position and long position. So in general, basically it is much better prediction than the random algorithm. The random algorithm basically, is kind of random. Okay, so it will not do much, say, meaningful prediction, but for this one, then the profit is kind of meaningful. Okay, so maybe you can try on your own machine and run it on different kind of data in order to try to get some idea or something. Okay, but of course, this is only one way. As a matter of fact, many of you have tried in the previous semester, of course. So if you try, one is PQM, is very commonly used. They use with it. Using deep neural network on pure learning. There's also other more advancements. Okay, so that's all for the reinforcement learning. So let us take a 15-minute break, and then when we return as 40, not 8:40. Yeah, right. 8:40. Okay, then we will start the new topic. Okay. So now we move on to another topic that is somewhat different fundamentally from what we have described earlier. What we have, the machine learning technique that we have described basically is learning from the inherent property about the data and using it to discover it in order to make good prediction. So all the training knowledge are from the data itself, so it's intrinsic. On the other hand, now we are working on another source of information or knowledge that will help us to predict the stock price or to predict the financial trend of some market. So basically, we are, instead of looking at the data itself, we will try to evaluate or get information from other sources in order to help us to make better prediction. In particular, one very important source is public opinion. And as a matter of fact, in my generation, all our, say, parents, uncle, aunt, using public opinion to do their investment. So basically, I still remember when I was young, that all the people say that, they got, sorry, I think you know, Cantonese, okay. So everyone know that Lei Ka-shing, okay, is very good. So follow him, follow his decision in trading the market will always be a good, best way to do that. And now, about 30 years ago, then we have a PCCW. So at that time, everyone say that, okay, the chairman of PCCW is the son of Lei Ka-shing, so it must be good. Okay, so this is the public opinion. And at that time, we almost all of the Hong Kong local people will just focus on, say, dumping all their access, okay, and into the so-called 白兔仔, okay, the ticket for the PC stuff. Okay, why? Because public opinion, okay, say that Lei Ka-shing is very good, is very rich, and anything related to Lei Ka-shing is also very good. In particular, this so-called 白兔仔, the chairman is Lei Ka-shing's son, so it must be very good. So public opinion say that, don't worry, okay, just invest all your property that you have, okay, and then you will be good. Okay. Then after 1 or 2 years, then it kind of the price will kind of cut by more than half. Okay, so basically, but anyway, this is public opinion, and a common say knowledge about the market is that public opinion are important, and we should take them into consideration. Okay. And based on this, there are many computational techniques that will just make use of public opinion in terms of how to assess it, how to understand or interpret it, and how to make use of it to help make better prediction. Okay, so this kind of making use of public opinion is a very important new technique in improving the stock price of financial forecasting capability. Okay, but in this say area, it will kind of need to make it automate this process. It needs to involve 2 different areas of AI. The first area of AI is machine learning or supervised learning. Okay, that we do. But at the same time, if you want to make this public opinion into consideration, but you want to do it automatically, then you need to develop a system that can kind of understand, okay, the media in order to have some idea on the public opinion, and this involves natural language processing. Okay, so this kind of fusion between machine learning in traditional machine learning technique and the natural language processing, they technique together and in order to decide this part is called sentiments analysis. Okay, from this understanding of the natural language that we can determine, okay, for every pieces of information, whether this information will give a good opinion or bad opinion on what we are interested in. Okay, so this is called the sentiments analysis. And there's a lot of platforms, okay, that we can use to get the data very easily. And in particular, I have, say, for this course, I have applied for a Twitter account in order to get used the twist in order to, say, run some example on using this technique. Okay, so this is what we are going to do. Basically, I'm going to first introduce some traditional approach. And as a matter of fact, sometimes we find that this approach is even better than the one that you generally use machine learning. Okay, and after that, we will just use a quite simple but powerful tools called FAIR, that will say understand some package, okay, as a natural language, and then it will try to say make a decision on whether the message are positive and negative. Okay, and after that, then we will give you more example on that. Okay, now, but let us first things first. Let us look on in general how to make use of what we know in order to do some sentiments analysis. And here is give you an example. Basically, what we are going to do is to build a system that will make use of some, say, critics over the last 20 years that have been published in New York Times and all other, say, critics, and then we make use of their review in order to kind of implement a example on determine whether a new review will give us positive or negative opinion. Okay, so how to do that? Basically, it evolves naturally to natural language processing, but it is not directly applied AI technique. Okay, and it is kind of a standard traditional programming method. Okay. Now, here if you say many of the steps that a traditional AI or a natural language understanding program need to do, okay, and I don't want to go through it, but in particular, given the passage, what you need is to clear up the data. Okay, in particular, you want to say divide or pair up, group the character into word, so that the basic unit is not the letters, but starting from some meaningful word. We call it the tokenization. Every token, in order to use it to help us to process data much more meaningful. Okay, and there's also other stuff that is not too much related to what we want. Okay, so maybe you can just skip. Okay, so maybe you can look at it. It's pretty straightforward. Basically, the last step is very important. So what we are going to do, or what we want, is we want to, let me see. Yeah, this is a general method for understanding the document. And in general, what we want to do is, given a document, we want to classify it into different groups. Or in particular, in our case, as I will class it into two groups. Okay, the document will be in the positive group or document in the negative group. Okay, so basically we want to do classification. And what we need, is this general picture. So basically what we want is, given the training data in which this is a document. Now this document is not the primitive sequence of letters that will comprise as a document, but instead they have put all the necessary processing that I mentioned here, such that each document is just a sequence of work together. And then this is a supervised learning, so every document will be associated with a model answer, the class that it belongs. Then after that, we will use it to train a model using some algorithm. Whatever method that we will use, not necessarily a machine learning method, but anything that will help us to build a model, so that based on this model, then given any document, we can predict what is its class. So in our cases here is, given lot of document or in the review, of the movie, each of the review, we will look at whether it is a positive review or negative review. And based on this information, we'll build a model or a program such that this program now will help us determine for any critics whether that critics are positive or negative. So this is what we want to build. Okay, so how to do that? And the most important thing is now there's two ways. One way is look at the whole document. Of course, you translate it into a way that is suitable for say neural network training and feed it in the neural network and do the training. Okay, so this is what we are going to see when we use the FAIR, machine learning model driven algorithm. But also we can do it in some non-deep neural network way. Basically, let us look at what we should do. Now, if we look at a document, so it comprises with many different words. And in order to decide whether this document, which is a critique for some movie, whether this document are positive or negative, then basically what we need is not look at all the words in this document, because many of them, may not convey important information about, whether this is a positive or negative document. So in particular, what we really need to concentrate is some set of particular word that we know will convey some positive feeling about the movie, or some particular other set of words that will convey negative feeling about that movie. Okay, so this is the key observation that we are going to use. Namely that we will first prepare, as a processing, large set of words that we know will be belonging to a positive, message, and other group of words that belong to negative message. Okay, how to do that is not easy. Okay, you have to done it manually. Okay. Usually, this group of verb will be more than 1,000 different set of words. For example, good, happy, exciting, and that kind of thing will be positive, while boring, horrible, terrible, it will be kind of group of negative. Okay, so once we have these two groups of words, then we can base on it to help us to classify our document. So we believe that in general, all the critics will kind of use the same set of usual words to describe the movie. Okay. So what we want to do will be giving the critics, after doing all the so-called tokenization, to extract the right word, every word, and then for each of the word, we may decide whether first it belongs to the positive group or belongs to the negative group or belong none of the group. Okay? That from all the same word in this document, then we do the simple counting. How many words in it belongs to positive? How many of it belongs to negative? And forget about all the others. Okay? And then based on this one, then we will believe that the critics, if it is really like the movie, that it will use much more positive word. Of course, it may have some word that is not that positive, but still positive word will be dominant. On the other hand, for a negative sentiments about the movie, then it will be very negative word. Okay, so it gives us a very simple approach here. Without real, say, machine learning, you just count the positive and negative word. Okay, so this is what we are going to do. Okay. Now, once we have this idea how to implement it, one way to do that is just the counting. But here, it also can apply this idea to, okay, with machine learning technique, to mix them together. Okay, in such a way, then one way to do that will be not just counting the word, but instead each critics will be represented by the same set of words that include all the sentiments, say, word, either positive or negative. Okay, so basically, the input will be based on all the sentimental word. Okay, and then how to classify a document? Basically, we will just use a 0 and 1, okay, to show whether the word exists in the document. Okay, for example, in document 1, we find that it contains word good, contains word attractive, but does not contain word rubbish. So basically, its representation input will be true for the first word good, true for the second word attractive, and false for the word rubbish, and so on and so forth. So you will see that now each document will represent a vector of true and false vector to show whether that document contain or does not contain the corresponding, say, sentiments word. So this is kind of a very important information about showing the sentiments of the critics. Okay, and then of course we have a model answer, and this can be justified as whether it's positive, negative. But after all this, that all we need is to feed it into a machine learning or classification, and then we have a model. Okay, so this is what we have. So this is what we have. Now, here it gives you an example that how to make use of this. Okay. And in this example, the data that we are going to use are from a library, okay, from NLTK, NL, Natural Language TK, 2K. So basically, this is kind of prepared by the research community related to natural language understanding, that it provides many material for the student and researcher that are interested in machine learning in order to have the data and supporting function for us to learn or teach natural language processing technique. Okay, so basically, we have our example will be say pick from this natural language toolkit. Okay. So what we are going to do is to apply the idea that we will first decide the set of words that we will use, and then we will prepare the representation of every document, and after that, then we will this kind of input document true false together with the sentiments, okay, and then we will make use of one model that we have, say, explain, okay, it's called the naive Bayesian classifier. That is a standard classifying machine learning method that if the input, it will classify into groups, okay, and then give you a model to make the prediction. Okay, so let us look at this one by one. So first, we input the toolkit for us, okay, and then we need to input the set of words that involved in the review. Okay, so in order to do that, we first from this toolkit we import the movie review that contain a large set of movie review from which we can pick some of them for us to do the training. Okay, so after that we download this movie review. Okay. Now let us see what we have. Now, after downloading this moving review, then we have a model with NLTK that we can just look at how many words that it has by calling this function. So this function, this frequency distribution, basically, it's a standard system function, and then we just go through a for loop to trace through every word, in the movie review. So we group all of them together as one group, many thousands of them, and then for each of them, we convert it into lowercase to just make sure don't want the case of the letter will kind of separate same word in a different group, and then we just do the frequency counting, and then this will restore it into a list of all words. So this is what we have. So after this step, basically we just work out all the data of a document in movie review, and then we choose frequency counting, and then we find that out of this review, common is the most frequently appear token in all these documents. Other than that, the next one is the token either, and then colon, and then A, and then N, so on and so forth. So this is kind of this will just group or just rank all the frequency words appear in our data set. Okay, so now after that, basically we will just use this word together. Now, remember, we need to create an array. That array that have all the sentence word together, such that use true, false to say as a representation of that word. Okay, I'm lazy. I don't want to go through and find all the word together. Okay, so what I'm going to do is I just want to illustrate, okay, the idea. Okay, so hopefully you understand. So I'm now, instead of use the actual sentence word, I will just use this list. Okay, just replace them by the most frequent word and next most frequent word. Okay, and then in particular, I will use the first 2000. Am I right? Features word, yeah, should be 2000. Yeah, right. Okay, so the feature is only 2000. Okay, so what I'm going to do is to look at all the words in this database and then use the frequency distribution that to count the occurrence of every word in this set of words, and then sort it together such that the most frequent word appear in the data set will be come first, which is in this case is come. Okay, and then this is third for the second word, and so on and so forth. Okay, so now based on this, our say document will be look at this one and then find if the document has comma, then the corresponding say feature will be true. If it has third, the corresponding feature will be true. Okay, so this is what I'm going to do. And also in the database, every movie critics, it will also have a label saying that whether these movie critics are positive or negative. Okay, so basically we've just used this to create our training data set. Okay, so this is what we have. Up to this point, we have word features, okay, which is kind of this list of words, and it will have true if the document has this word and so on. Okay. Now, next, we will want to create a document. And you will see that maybe we look at this one first, okay, one by one. Okay, so this is the how to say, for every file ID, so we look at here. Okay, this is what we have. Basically, the movie review data set, it is divided into category, and as a matter of fact, there's two categories, positive or negative. Okay, POS and NEG. So it has two categories, and for each category, it will give us a file ID on that category that will be used to assess all the critics, one by one, using this file IDs. So what this statement doing is that it will go through all of the two categories one by one. And for each category, we just go through the file in that category, get the file ID, and then we use it to get the word appear in this file together with the its category. Okay, so first is positive, next is negative. So basically, you will see at least something like that. Okay, so at the end you will see one, and after doing that, then this is the example of the first document. On the first document, basically you will find all the words appear in the document together with its category, and this is for document 0, and then document 1, and all the documents in the data set. So this document basically will be a list of words appear in the document together with the label. Okay, so this is kind of come directly from the organization of the NLTK database, okay, in the category. Now, the maybe we skip it and then we go to here. What we basically need to do is we have this set of documents. So what we are going to do first, we shuffle this document, okay, to make it random in order to create a useful training data set. And after that, we just first we have a function called document feature. Okay, later I will explain it. This document features basically is the first 2,000 words that I mentioned. And for each of that, it will set the word to true if the document has that word, and set the features to false if that word is not in the document. Okay, so this what we are going to do here is create the training data set. What we are going to do here, we check it, is for each of the documents, just like this one, then it will create the 2,000 array, and for each of the words in the array, it will set it to true if that word is in the document, and false if it is not in the document. Okay, so this is the input for the document, and also this is the positive or negative group. Okay, and here basically is the training data set. Okay, the data set, the document features, and then the label answer for every document in our data set. Okay, a feature set, and then because we take the random, so basically it's already shuffled in a random state. Then after that, then we use the first 100 data set as the test data set, and then the following remaining feature set as the training data set. And then afterward, all we need is to call the classifier to do the training on the training data set, and we will have a model. Okay. After that, then this model we can use it to do the classification. Okay. So basically, in this, after the model, then this one is give you an example on doing the classification. Okay, so this is the word feature I have explained. Maybe you go through it together yourself. Okay. Now this is the classification. Basically, after we train the model, then in the testing data set, the first argument 0 is the feature list if you still remember. Then that they give you the model, that it will give you an answer. Oh, this is a negative. Okay, and that. Also, it give all the data set to the model and to compute the accuracy. And you see that the model that we have trained, the accuracy is around 0.85. Okay, it's amazing. Okay, because you see that the feature data set basically is just we get from the most frequency word, second most frequency word, and so on. This is the first 2000 appear most in the critics, and we'll just use it to do the classification. It still gives it a very good, okay, accuracy. You don't need to say really have understanding on whether each of the words are positive or negative. Okay, so this is what we have. And there's another function that maybe you don't need to understand. Okay, but it just tells you that out of this 2000 feature word, out the most say informative feature out of that is outstanding. I don't understand this word. Molan, what does it mean? Seagull. Maybe they are actor, am I right? No. Okay, and then the word wonderfully and Chapman and so on. Okay, so this gives you the information. Okay, so this basically gives you a simple idea on how to make use of the traditional machine learning method. Let me summarize what we have done, and then maybe you can go through the program to figure out yourself that indeed it is doing what I said. Basically, what we are doing will be go to the database that contain all the pretext, okay, provided into the NLTK library. And then what I'm going to do is to go through all the words in the document, and then we count the number of occurrence of this word in all this document. And then we start, okay, in ascending order, a descending order, such that the most frequent appeared word will be on the top, and then the next most frequently appeared word in the second, all the way up to the least appearing. Okay, and then we just chop and the 2000 first 2000 most appearing word. Okay, and then this is the features of our input. What we are going to do for our training data set will be, for each document, we will create such a feature list, and then for each feature, we will put it true if the document contains this feature or word, and false if it does not include the feature word. Okay, so in this case, we create the input together with the suggest answer provided by the NLTK database. Okay, and then we just feed it into a machine learning called naive-Bayes classifier. Okay, basically it's similar to one that we use, okay, to classify apple and orange, apple and pear, if you still remember. Once we have this one, then basically everything is more or less what we have gone through. Fit in the data set with the model answer, and then we get a model, and this model will help us to determine the class of the document, whether it's a positive or negative. By simply given every document, we just create the feature vector for that document, and then feed it into the machine learning model, and then it will give us the prediction. Okay, so this is what we have. Okay, now let us say move on from older technique to the latest technique. Okay, so everything here that we are targeting or need is the capability to understand natural language. And this is not easy. As a matter of fact, in my generation, there's even some people who believe that it is not possible to have a machine to really understand what the human being use to do the communication. Okay, but after all this year of research, basically, we will eventually have the very, say, kind of crazy tool like ChatGPT that will behave as if it is a human to understand. Okay, basically, what I'm going to explain here is some, say, latest development in machine learning in natural language processing. And as a matter of fact, the major breakthrough in this area of research is the introduction of a new network architecture. It's called transformer. This transformer is very complicated, very deep neural network, which every component has a specific purpose, and then we will try to say use it. You can have a very good performance for natural language processing, and this neural network transformer also have application in computer vision and all the other applications. So this word transformer is a new architecture of neural network that we can use it to do very, say, important thing. Right? Well, good. Okay. Now, as a matter of fact, before transformer, basically the LSTM are also a very powerful tool for us to understand natural language. As a matter of fact, natural language understanding can also be viewed as a problem in time series analysis, because the word between in a sentence or in a paragraph, basically the sequence of words will have relation. Just like LSTM for stock price, then the stock price movement also have some kind of relation. And by knowing this relation, basically, it will, say, help you to do the translation, say, for example, understanding. Okay, for example, you already understand that happy and am, okay, as a two previous word, and the new word here usually is for the subject. Okay, and that is, so the kind of the previous word will help us to make prediction on the next stage of the word. So this is kind of natural language processing. So what I'm going to say is this will LSTM is already a very powerful tool that people use to apply on natural language understanding application. Okay, so this is what we have. Okay, but the problem is the kind of the long and short-term distinction are not good enough to make the best possible usage of this idea. So one major breakthrough that in this area of research is some research group developed a new architecture on deep learning. It's called transformer. Okay. Basically, transformer is also aimed at doing time series analysis. Okay, and this is what I copied from the internet, and you will see that I really don't understand. Okay, it's just a very high-level explanation. You can imagine that each of them will be a lot of, say, neurons work together and very complicated. Okay, but this is what kind of the breakthrough that you may interest to know. Okay, that 2 or 3 or 4 years ago, Okay, we have a transformer architecture that we find is very powerful in understanding natural language processing. Okay, now once this transformer has been proposed, then the research community has already known that this model will have tremendous impact on the natural language processing field. So after that, then there's a lot of big company and research organization is start to try to train model that will be used to train, okay, transformer that is have the most complicated, say, architecture in terms of, okay, the computation power good enough to train this most complicated structure. So after the introduction of transformers, basically there's different groups, okay, several groups in the world that start to compete with each other, that build the most complicated this transformer model, and then try to get as many good data in order to train the model. Okay, one of them will be work by ChatGPT. Basically, one of the kind of a good story about ChatGPT is, in fact, the company hire many workers in Africa in order to do the actual, say, labeling of the data. Okay, so they have the enough very powerful machine to do the training, and at the same time, it involves a lot of resource to prepare a very complete data set. Okay, and for some, they also kind of consult experts in order to solve some particular problem. So they use all different kinds of, say, resource to try to build the best model. Okay, so now the problem now is that everyone knows transformer has great potential. Everyone wants to build the best model trained on it. Okay, and in particular, ChatGPT is kind of one of the first. Okay, that have built enough complicated enough model, and its performance is kind of a breakthrough for everyone of us. Okay, so as a matter of fact, sometimes I need to write some press release for the department. Okay, to be honest, press release is kind of straightforward. So once you know, you write the first press release, you know how to write the second press release and third. Okay, basically it's exactly using more or less the same kind of structure and same kind of work. You just fill in the detail. Okay, but recently I just kind of asked ChatGPT to help me to write the press release. So I do this. Okay, please help me to write a press release that includes the following points: 1, 2, 3, 4. Okay, and then click, and then eventually it will have a very completed and kind of impressive press release. Okay, so basically the technology now become very impressive and powerful. Okay, so this is what I want to say, spend some time to explain it to you. Okay, and now I don't want to go through it in detail because it's not that related to our topic, but anyway, this is quite kind of interesting. Okay, this is the history. Okay, basically the model, transformer model that I mentioned is from the paper in 2017. So at that time, then we would basically they use the model to build some application. So as a matter of fact, later you will see that we also use the so-called BERT model to do sentiments analysis, okay? Because it is also a very good method to understanding natural language. And after that, and 2018 and up all the way up to 2020, where the OpenAI has spent a lot of, say, resource to build, okay, at a kind of a very large transformer model, and eventually it will have the ChatGPT 3.5, because this eventually will show the power of this transformer model and become one of the major tools for every one of us. Okay. Okay. Now, basically, this is a all the slide here is very easy to understand. So maybe I leave it to you to go through it yourself. Okay. If you are interested, of course. Now, what we do next is to make use of some natural language library in order to help us to understand kind of a message and this document in order to decide whether the document are positive or negative. Okay. As a matter of fact, you will find that there's a lot of tools in the market that will do the following thing, namely that giving a document that tool, instead of do the translation and that kind of thing, it will just give you, okay, either classify either whether the document are positive or negative. There's a lot of tools available. So as a matter of fact, over the last few semesters, many of your classmates has tried many different tools to do the sentiments analysis. Okay, and here is one of them is called FRAME. That is kind of a very commonly used tool, at least a few years earlier, okay, to help to us to do the sentiments analysis. Okay, but before we maybe we don't have time to go through the program, but I just want to say something about sentiments analysis. And you need to understand the limitation of sentiments analysis. So for we want to say use sentiments analysis for us to make better prediction on stock, okay, price, for example. But what I want to say over the last few semester, after say discuss with the students of different projects, what we find basically is so-called sentiments analysis give us a pretty good idea on how the sentiments of the public opinion and the stock price are correlated. Correlated, that means that one rise, the other will rise, one fall, the other will fall. But correlation has nothing to do with the causal relationship between, okay, these two entities. So we find that, as a matter of fact, the sentiments analysis that are in the project, the conclusion more or less is they have no use, okay, because even though they show a very evident, okay, clear evidence that the two measures are very closely related, but you never know which one caused the other. So in some case, of course, we want is whenever I see a sentiments high, say a jump of positive, say sentiments, then it will imply the positive stock price. Okay, but I can tell you that in many of the studies, it's not true. It's the reverse. It's mainly that in the 1 or 2 days, that 1 or 2 days period, that when the stock price increased today, then pretty soon, at the same time, the public sentiments of that stock price will increase. So in other words, even though it is clear that sentiments and stock price have a close relation, but we still cannot say have a clear idea on whether the stock price will help the sentiments or whether the sentiments will encourage people to invest in stock. Okay, so it's kind of sometimes the technology seems useful, but when you actually say try it, sometimes you see a different story. But of course, this is what we have found in this course, but I'm sure that in the real world, there are some other, say, statisticians and experts in order trying to get more meaningful inference instead of just use our usual, say, covariance matrix in order to show they are correlated. Okay? So, but anyway, we will just demonstrate how to compute the sentiments of the message using some existing tools. And then we will also show you, okay, the relationship between sentiments and the stock price. But we didn't say, okay, which one will cause the other. Okay, so this is what we are going to do. Okay, so maybe we stop here. And next week is the reading week, and then see you after next. Okay? Thanks.